right? Covered everything which is considered non-object-oriented part, syntax and stuff like that. Everything, as we have seen, everything which is native, not native types, everything is implemented with classes in Java. And today we start looking at Java classes and how they deal with namespaces via packages. Okay. We will try to compare constructors as provided by Java and constructor provided by C++, and I will ask you to tell me what differences you see. We will look at overloading and see what final keyword does in Java static members compared to C++ static members and packages. These are good websites, so to enrich your knowledge. We have seen classes because they are needed for everything you write in Java. Today we will look into more details. First rule, and be aware for your assignment, optional assignment, only one class in a file can be public. So if you plan to put more classes in your file, and you will have to do it according to assignment specification, for your optional assignment you have to put 6 classes. Only one will be public, the one where the main function is implemented, because that will be the entry point, and you have to give the file name that name. So your program for optional will be main, your file will be main Java, and you will have public class main, and here you will put your main method. And then you will write all the code from your assignment 1 part 2 from main method in C++. Declare objects of various type, temp, whatever, and display information about them to demonstrate polymorphism. And after that, you can list all your classes, but none of them will be public. You will have class salary, employee, class employee, but you skip this. Okay, so be aware. Otherwise, you get errors. It's not recommended to use this approach. It's better to put each class in your file in general, but not for this assignment, because I want you just one file. Don't work with compression, zip file and stuff like that. You can do like this. You can put more classes in one file as long as one is the main class and the other classes are helper classes. Helper classes, it's possible. You have seen some helper method for previous assignment, create and copy. So you can have classes with similar goal. Right, so as long as you declare your, in general, your classes in the same directory, the compiler will find them and will use them appropriately. Assume that you have a class called example in one file and another class called my class in another file, and they are in the same directory. Then, in order to use this my class here, assume that we have you don't need to use import or anything, as long as you have them in the same directory, right? You can use them straight away. This is the default visibility way for Java, the default, right? The Java compiler does like that. It looks for your classes in the same directory, If it doesn't find this in the same directory, then it goes to its bin where it has library files. If it doesn't find it there, then it starts complaining. You get an exception. But this is something you probably will practice for tutorials mostly. As you can see, every data member, which is called a field in Java, as I said, and every method has to specify its visibility. If it's not specified, if this is missing, it means that is the package visibility. Okay, so it's good to put everything, private or public, and you will see protected is there. There are these three keywords, and they have the same power like we have seen in C++. Whatever is public is available to outside world, private is available to the class itself. Right. There is no friendship in Java, so private are available only to the class itself, or derived classes via public methods. Anyway, this is similar. And this simple code demonstrates those public-private features. Every class comes with a reference this, and it is used for disambiguity, either to access data members which are hidden because their names are used in a different context, or, as you will see, like a constructor. But this is something very specific to Java. As you can see here, we have two fields, X and Y, and then we pass as arguments to the method distance squared X and Y again. So, to distinguish between this method, this field, and this parameter, we use this, which is available in C++ as well, as you know, but the syntax is different. You have to use either dereference this or the arrow, okay? So, the best way is try to use different names for fields and parameters. But this is one place where this is used. Notice the syntax. Okay. So, as you can see, in this environment, in the method itself, the local parameter hides the class members. So the hidden data here are this X and Y. Inside the method, this takes precedence. We don't have scope operator in Java, so this was the way to deal with variables at different level. Now, for our class circle, we have 3 data members. Remember, we had a circle in C++, and this is a constructor. Now, can you point out similarities between this, the constructor in Java, and constructor in C++? One similarity. One similarity. Sorry? Yes, it does initialization of data members. So constructor initializes data members of the class. Another similarity. They can be overloaded, which is not exemplified here, but it's, they are type. Yes, it's a special method, no return type like in C++, correct? The name is the name of the class, like in C++, right? So there are similarities, but you will see there are differences. If you don't put public here, which is not recommended, this constructor is available at the package level. If you don't put public in the class in C++, the constructor becomes private. This is a default. If you have this in your C++ circle class, nothing here, this is a valid constructor, but it's private. And being private means no outside world can construct circle objects. And you will see when we talk about patterns, this is used in some cases. So a difference, the default way, handling coming from Java's default way. Another difference, Java does not support default parameters. So the only way to provide for default constructor and custom constructor is overloading. You have to overload them. In C++, you can combine them in one via default values. Another thing which is different, if you look at this constructor and you think about constructors in C++, we use initializer lists. They are not available here. All right, so these are some of the differences. Java comes with reusing code. Instead of writing this code here, which can be obtained from this function by assigning 0, 0, and 1, right? When we call this constructor, we invoke it with 0, 0 for the second one, and 1 for the third one. It's a repeated code somehow. Then they had a shortcut. We invoke this constructor, but via the keyword this. So when you use it like that, you invoked a function which is there. What is interesting is you can invoke this function before it is written. You see? You call it here, but you write it here. Java does processing the whole file and does a checking as it goes. Kind of, it's the checking done by virtual machine is a little bit more complex than the one that's in C++. In C++, if you use something before you implement it, you are in trouble. But in Java, it's okay because all the checking and implementation calling is checked. Not exactly straight away, but by the end of the file, somehow they can do it. So, this is a way to economize code writing. Interesting enough, C++ 14 has started introducing this approach too. There is something similar in C++. So as you can see, languages borrow from each other if something is good. Like in C++, if you do not define any constructor, you can use the objects because there is a default constructor. And like in C++, as soon as you define a constructor, the system default constructor will no longer be available. So you have to make sure that everything is done properly. And in particular, default constructors are very important because data in Java, as you probably remember, are initialized everywhere. They come initialized except inside methods. In the methods, local variables are not initialized, but in arrays, in every other environment, they are initialized, and they are initialized by the default constructor. So, looking at the copy constructor, a big difference. We don't have the reference operator here. So this syntax is much simpler. When you define the copy constructor, by default they are called by reference. Remember, every object is a reference type. So what this does, very simple, initializes this current object fields from the argument passed in fields. Right. Difference between C++, you have to invoke the constructor, copy constructor, when you declare variables and you use this copy constructor. Remember, this C2 equals C1 was used in C++, and we called copy constructor, which was a little bit confusing. So this notation, so it will have C1 defined completely. This is complete definition of the C1 object. And now we want to construct, we introduce a new variable in the scope. C2 is a circle. It's up to here not properly defined. It's just saying, okay, C2 will be a reference object, but what is the object itself? We have to provide information, either with a constructor or constructed from a different circle object. In C++, this statement was allowed to be C2 equals C1. And this was calling the copy constructor. But in Java, C2 equals C1 will call the assignment first. Wait a minute. But we are working with the same memory location. So in this case, we have C1, C2 pointing to the same circle object. In Java, this is Java, this was C++, and this was equivalent to C2 equals copy constructor, I will say copy constructor on C1. So with this notation, what you get is, with the Java notation for copy constructor, you have your object C1 here, and then copy constructor C2 C2 is new circle C1, you get another memory, and you get these three data members copied. Remember that code we have seen. Code here, mx gets the value of mx, my the value of my, and m radius. They are deep copying. So, operator overloading does not exist in in Java, sorry. Operator overloading, with one exception for string concatenation, they are not allowed. As I said, C1 and C2, when you do assignment in Java, you will get pointing to the same memory. So at this, after the assignment, everything will point to a circle with these data members. And you can't change that behavior. You can, but where was it? Deep copying, you can perform something. You have to define a method. No destructor in Java, which is a blessing. Garbage collector is a mechanism which can assess whether an object is still needed. And if it's not needed in the program, then the memory is returned. And it's done in a very safe way. Sometimes you might want to perform some house cleaning before the destructor, the garbage collector, cleans the object. In very special circumstances, when you have complex situation, multi-threading and concurrent programming, they might need to do some closing of connections and stuff like that. Then that code is put in a method called finalize. So finalize in theory is processed by the destructor provided by the garbage collection. But there is no guarantee that the garbage collection will call that one. It might, if it is there and consider that is necessary or require some cleaning up, then it might invoke the finalize. So the only way you can put some code but never delete or something like that, maybe just set size to 0, very simple things in the finalize. Every other method can be overloaded. We have seen constructors overloaded. Here we can provide some conversion from integer whatever to float in some sense. If I is int, here to set m radius, which is a float, we can do this most correctly. Specify float I, just to avoid any problems, because Java is very picky about conversion. So you can overload based on the same rule. Different number of parameters or different type of parameters, nothing else. Class method and class fields. Like in C++, static keyword says that something is associated to the class. Remember, math random, math was a class, is a class in Java, we have math class, and we call random method or math square root or something. These are classes, and they come with methods which are associated to the classes themselves. And they are always public static in order to be available to outside world. And the most used public static was main. Now, every method which is not static can work with data member which is static or non-static. Every method which is called instance method, like this one, this is not declared to be a static. Okay. But every method which is static, it has to work either on static data members directly, like here it has direct access to static data member, or it can access static data members via reference objects. Right. So here we have the constructor for this class. As you can see, it's not a static class, it's a normal class. But it comes with this method associated to the class itself. And this has the power to work with these types. And then we declare objects of this type, as you can see, invoking the default constructor which updates the static data member, increment by 1 every time a new object is created. So at the beginning we start from 0 and is incremented to 1, default value 0 to 1. Then another object, this is incremented to 2, this is incremented to 3. Therefore, when we invoke this method, we output 3. So, as I said, we can invoke static data member via references, like here. Static count class, right, is the name of the class, and invoke its method, like we have here. And this is private. If we put it public, we can invoke num instances on the static count class itself. It is public, which it's not a good idea. Java doesn't have a constant keyword. It is reserved in the table of keywords, but is not used in Java for the moment. So the equivalent of this is final. So be aware, whatever is constant and you can't change, being it a class, a method in a base class, and you try to overload it in the derived class, if you put final in the declaration of the method, you can't. So final is similar to C++, but with a small change. You don't have to initialize final variables when you declare them, and it was considered a better approach. More flexible restriction, because you sometimes don't know what the initial value of your constant variable should be. Normally, if you have a constant variable, you can set its value in the constructor. you put it, constant data member in the class, but don't give any value, and the constructor sets the value, and it stays glued to that value from that moment on. So, you can apply final to a method. It can't be overridden in a derived class. We will talk about inheritance soon. And this has good use. Unexpected behavior in a subclass shouldn't be allowed in some cases. A class itself can be declared final, which means the class cannot be derived from. It can't be extended. Important classes are not derivable. So here, notice final, it says this class cannot be used in inheritance. In this example, we have a final static data pi there, which is initialized straight away, but we have a final data, m final value, which gets its value in the constructor. So you have both approaches. This is not allowed in C++, as you know, but it's allowed in Java. And here we have a method, final, which if we wouldn't have here, this class would have been derivable, and then with this final here, this method can't be overridden in the derived class. So method can be final. This is an overkill. This class can't be derived at all. And because it can't be derived, doesn't make sense to overrid this method, right? Okay. But assuming that this was not, the class was not final, this class can be derived, therefore we prevent this method to be overridden. And the last issue is packages. It's the mechanism similar to namespaces, but with a different syntax and different concept behind. In Java, in order to avoid name clashes, they introduced grouping classes based on directories. For example, we have a directory folder called Java, and this is Java package. And that folder contains subfolders: Java language, Java utility, abstract, Windows toolkit, package. So these are subfolders here with this name, and the files here start with package lang. What the compiler does when you use system class, for example, it looks in Java directory, and then it has mechanism to know that a Java directory has to go to Java language and system class. The notation normally is java.lang.system. And sometimes we use this notation. So the dot gives the path. Look, import Java utility. We don't have to put this because it's part of the what system does implicitly for you. But when you put this tells the compiler what path to follow in order to go and use specific classes. So import is the keyword equivalent to include in C++. When a package is not declared for a class, it gets a default name. You don't have to worry about this. You don't use package in your assignment, optional please, because it might mess up our testing. But to create a package is very easy. Put the name package example, and then you declare a class whatever you want. Our computer science minds, I use the same name, example, but anyways, a different capitalization. And if I want to use my class example, I have to say import example, and I use it in a different thing. The Java compiler looks and tries to follow this path to get hold of my type example. And each folder where I have package example, each file where I have package example at the top should be in the folder called example. This means you have to align your files with a directory. The directory name has to match your package name. Okay, we won't practice much with the packages. It's good to know that it's a very simple system to design paths, and this is used for finding files, as we have seen previously. Files, directory are treated via similar tools in Java. And with this we have covered that, and start on Wednesday talking about inheritance, and with that you can solve your optional assignment and finish. So get 5 minutes late. Finish your work for time being. Thank you very much. So there is a lecture Wednesday, Thursday, tutorial Friday, last tutorial Friday with Java exercises. And after that, next week we will have only lectures.